Hello. Landreni pamene tikupitiriza lesson yathu maphunziro athu la masamu tikupanga similarity term lesson 2 ndipo lero tikhazikika pa area of similar figures ndipo muli ndine Sisala Juma. Last lesson, in lesson 1 tinapanga kwambiri scale factor. We showed each other on how to find a scale factor, so we are going to build on that to find other factors zimene zingathe kutithandizira kuti tipeze area of similar figures. To find area of similar figures is quite very important chifukwa pamakhala zinthu zina zikuluzikulu kwambiri zimene ndikovuta kuti muthe kupanga kupeza ma areas zake or ma dimensions zake practically. So you can use a figure which is just similar to that and calculate the area of that other figure or image. So let's be together and see how we achieve that. Let's look at another factor today, which area factor. And the area factor is basically just a ratio of areas which are similar, of similar figures, that is. You may have two figures as shown. You may have figure 1 which has area A1, and you may have a similar figure 2 which has an area A2. So to find the area factor is very simple. It's just the ratio of that. Area A2 divided by A1. So you find the area of that bigger object, you find the area of that smaller object. Then if you find the ratio of those, that should give you the area factor. Let's have an example. It's a very simple example. This saying you have a triangle which has we have two triangles, that is, one triangle is 24 centimeter squared area and the other triangle is 72 centimeter square area. So area factor, it's simple. It's just the area of image divided by area of object. In this case, our image is this one, enlargement of that one. If you just enlarge a thing, that's the similarity in there. So you have 72 divided by 24 centimeters square, centimeter square. So those ones we are going to cancel. 72 divided by 24. 72 divided by 24, that will give you 3. Yeah, so that's that, how to find area factor. The figures can be any shape. Can be a rhombus, can be rectangular, can take any shape. It can be a cube. Yeah, can take any shape. So to find area factor, you do the same. You just find the area of the objects, the area of the images. Then you get the ratio of that, you find the area factor. Okay, so basically that's that on that. Let's look at now, we have two things. As of now, we have scale factor and we have area factor. Scale factor and area factor. These two things, here we deal with length area factor you're dealing with length. Here you're dealing with areas. Okay, so there has to be a relationship between them. So let's show each other by demonstrating, by doing just a small demonstration on how you can achieve that. So now let us consider these figures. Let's have these triangles which are similar, that is. Then we can have maybe rectangle which are also similar. So on this one we can say that's maybe with length 2, that one length 4, that one 1, maybe that one 2, and we may say that height is let's say 1. Here maybe base maybe 2 centimeter. All these are in centimeters. And here let's say height is 2. And let's put base. Its base maybe let's just let's put 4. Okay, yeah. So this one looks to be just an enlargement of the other one. So in this scenario, let's try find one scale factor and area factor and see kule kuoneka bwanji. Okay, for scale factor of this one, we know that it's the ratio. Okay, we can choose any. If we choose the base to be 4/2, which is 2/1, that's the scale factor of that first part. Area factor, you'll find the area of that and the area of that. So area of the bigger triangle, we know it's half base times height, which is equal to half. Our base is 4, our height is 2. That and that will go, you remain with 4. Okay, that's the area of that. For the smaller one, the same, half base times height. It will be half times our base is 2 times the height is 1. So that and that you remain with 1, which means the area of that one is that one. So you will see that the area here, the area factor here, it will be the area of that bigger object, enlarged object, divided by the object. So it's 4 over, in this case, 1. But if you look at this one, it's the same as to say 2/1. I mean 1. So then 2/1. Okay? It's the same as that. If you expand that one, it will give you 4/1. Okay? And let's look at the second one. For this one, scale factor, we may choose any. It will be 4/2. And this one will be 2/1. Okay? And the area of this triangle will be length times height. So that is 8. That will be 8. And the area of this one will be 2. That one, that will be 2. So area factor will be equal to 8 divided by 2. So that 2 into 2, 1 into 8, 4. So it will be 4/1. This one as well, you will find out that 2/1. You will find out that this one is just 2/1, but squared. Okay, so kulizangofanana. One is just like that. My figures when they go fanana, but they could be different anyhow. Yeah, I just brought this just to demonstrate the concept, the relationship minute by minute. So if you look at it, mukangana kati 2/1, 2/1. So fanana. Only that area factor mangoipanga square scale factor. Yeah. So the relationship here ndio nena kuti scale factor will be equal to square root of area factor. All. Okay, maybe let me start in this way. The relationship here is that the relationship between scale factor and area factor is that area factor is equal to scale factor. This one should be F, not a C. Yeah, scale factor, but should be squared. Or mukoza upanga kuti ikale kuti scale factor we are capital going to be square root. It will be square root of area factor. Okay, so that's the relationship between these factors, scale factor and area factor. I hope this makes sense. So here we have a problem where we need to find the area of similar figures. So I will demonstrate what we discussed, we have covered, to get our to know how it is applied in finding area of similar figures. Yeah, so in this challenge, we are given two triangles which are similar. Two triangles are saying two triangles ABC and XYZ are similar. We are told that, and we are given that triangle ABC is 5 centimeters squared. So we have ABC, the area ABC area. We have area of ABC, which is 5 centimeters squared. But the question is to find the area of XYZ. So area of XYZ, for that one we don't know. For that one we don't know. So we are told, we are given the area of ABC, which is that one. But the area of that one we are not given, and we don't know. We are only given the basis of this triangle. So from the basis of the triangle, we can find scale factor. We can find scale factor. Okay? Let's find scale factor. So scale factor is the image divided by the object. In this case, let's say our scale factor will be equal to, our image is 8 centimeters divided by 4 centimeters. So that and that. So there it will go to 2 over 1. So that will be our scale factor. It's 2 to 1, or it's 2 over 1. All right. What about our area factor? From here we can find our area factor. Okay. Our area factor, we know that, but we can say but, because now we want to find the area, so we need to be thinking of area factor. Okay. But we can say that area factor will be equal to scale factor but squared. We have already shown that, which means it will be equal to 2 over 1 bracket squared. Okay, so 2 squared, it will be 4, 1 squared, it will be 1. So our area factor in this case is 4 over 1. Now for us to find the area of this one, but we know that area factor is equal to area of the object divided by area of, area of the image divided by area of the object. In this case, it will be area factor will be area of XYZ divided by area of ABC. And in this case, our area factor, we know that it's 4 over 1, which will be equal to, what is the area of XYZ? We know is 5 centimeter squared. In this case, we know that our area has to be in centimeter squared, so this one can go. Yeah, it has to be in centimeter squared. Anyway, we can leave it. So it will be area over area of ABC. Okay, so here it's a matter of making this one area of not ABC but XYZ. Sorry. No. Here we are making a very big mistake. Okay, the question is area of XYZ, that one, divided by area of ABC. Okay, so area of XYZ, we don't know that one. Don't know, we leave it. Area of XYZ divided by area of ABC, which is 5 centimeters squared. Okay, so it's a matter of making area of XYZ subject of the formula. If you make XYZ subject of the formula, you will have, so area of XYZ will be equal to, if you cross multiplication, you have that, it will be 5 and 4 will multiply, so it will be 4 times 5 centimeters squared, which is 20 square centimeter. So that object, its area is 20 square centimeter. So we have used scale factor, area factor, and their relationship to find the area of a similar figure to this object. Okay. Here we have another one, another example. So let's look at this problem here. They're saying two similar shapes have area 10 centimeters, 10 square centimeter, and the other one 40 square centimeter respectively. If the length of the smaller shape is 6 centimeter, find the corresponding length of the larger shape. Okay, so here we are using the same understanding now to find the lengths. Okay, so we are given the area of the similar figures, but we don't know the length of the other figure, but we only know the length of one figure. So we can as well use this knowledge to find the length of the other figure. Okay, so let's draw them. These are similar. I don't know its shape because I just told us the shape, the two similar shapes. We can put a whether circle or I mean maybe let's put it, because of the total of length, let's put maybe rectangles. And we can have two rectangles. Okay, this one 10 square centimeter, that one 40 square centimeters. Okay, they are similar. Okay, if the length of the smaller shape, so this smaller shape is 6 centimeter. It's any shape, you can choose any shape, but make sure that there's a length. You can have it, yeah, something like that. Okay, then find the corresponding length of the larger shape. So in this case, Afuna Mtipeze, that length. But we are given the areas. Okay, the areas. So first things first. Here we are given area factor. We are given, area. So we can find area factor. Area factor will be the area of the big object or the enlarged object to the area of the small object. So it will be 40 centimeters squared over 10 square centimeters. So that and that will go. So it will be, the area factor of this one will be 4 over 1. Okay. But this one can as well be written as 2 over 1. Something like that. Okay. So, yeah, something like that. Or maybe let's just take that out to show each other at a later stage. Let's not do too many things at once to make sure that when it's a same buoy. Yeah. So having this, we know that scale factor will be equal to square root of area factor. Okay, so square root of area factor will be square root of 4 over 1. Okay, so square root of 4 over 1 will be equal to 2 over 1. Okay, it's as simple as that. It's as simple as that. It's as simple as that. So we now know the scale factor. So how do we find the scale factor? In a sense, in this case, considering our figures. Okay, so let's say the length of this bigger object is x. So we can say that scale factor for our objects will be equal to x over 6 centimeters in this case. length of that big object divided by the length of the small object. That will give us our scale factor. I mean, the length of the image divided by the length of our object. That will give us scale factor. Okay. But we already found the scale factor here. We know it. So we just put 2 over 1 there, which will be equal to x over 6 centimeters. Which means that x, if you make subject of the formula by just cross multiplying, you'll find out that x will be equal to 6 centimeters multiplied by 2, which will be equal to 12 centimeters. Which means the length of this bigger shape is 12 centimeters. So reaching this far, we have that problem. They're saying a gardener has an area of 3,025 square meters and is represented on a plan by an area of 144 square meters. Find the actual length of a wall which is represented on the plan by a line of 8.4 meters long. Okay, so there is this problem. This is a little one. This is a practical one. Okay, you have a garden. Let's say and you have 3025 square meters. That's the area of that. Then you have a plan. A plan is just a drawing of this. It's just a small scale, a drawing for that. So in this case, it's actually one paper. Okay, you can have like that. Say that's 144 square meter. Okay, there's that plan. You can be on a paper, something like that. Okay, so having this, they are saying find the actual length of wall which is represented on the plan by 8.4 meters. So plan properly length which is 8.4 meters. Okay, so how is it represented? That it's very simple. We have shown that the first thing you find area factor. Okay, that is the plan. That's the actual thing. Okay, so in this case, so in this case, the area factor, how is it translated from the plan to the actual? It will be the area of the actual divided by that one. Okay, so it will be 25 square meters divided by 144 square meters. Okay, so you put that on your calculator. When you find that, find the scale factor. Okay, you have to know the scale factor. When you know the scale factor, using that relationship we have discussed, you should be able to find the length on this area, on this actual garden, represented on the plan by 8.4 meters. I leave this for you to think over it. I may finalize it next lesson, but I would like to leave you to practice, do whatever we have discussed, and come up with the solution. Thank you for today. Let's meet again in the next lesson. You were with me, Cecil Juma. Thank you.